Hello everyone. So today I'm gonna do a different style of video, I guess. And I'm gonna be showing you and I guess teaching you on the basics of circuit symbols. So we have a switch, which just looks like okay, let's just start from the beginning. We have a wire. A wire is just a line which crosses from one to another. Then we have a switch, which does look like a wire with a cut end, you could say. Then you have a I'm gonna go here. Sorry, I wrote this in the morning, so not very coherent. Then we have a resistor, which is just a line with jagged edges. It's also drawn like this, where it's a line and a box, but I don't like drawing it with a box because that could mean a lot of things. Now we have a potentiometer or a pot, which is again like a resistor but with an arrow pointed. So you have a resistance from here to here and from here to here, and additionally from here to here, like a normal resistor. Then you have a fuse, which looks like a wire but with a two dots and a this looks like a fuse wire, so that's why it's drawn like that. It's just a fuse wire like that. And then we're going to go on to stuff that takes in energy. So lamps, motors, and LEDs, motors, and lamps. Lamps are drawn with an X, a circle and an X. Motors are drawn with a circle and an M. And the polarity only matters if you put, let's say, plus here. That means the positive of the motor is coming into here, and the negative would be here. And then lamps are the same thing. So you could put a positive here, and that's what the lamp would mean. It's just negative goes here, positive goes here, and the lamp would light up. And then the LED. The way I draw the LED is with a diode symbol and two like arrows pointing out of it. Then you have the cell, the battery, and the supply voltage. So these three can be used interchangeably if you're just drawing out with theory. So like you can use just cell and battery, and usually there is a positive here, but it's known that the big one is positive, the small one is negative. But like if you don't know, you can still put a plus here. And everything is, as you can see, everything is indicated with plus because ground is indicated with these. So let me draw it bigger for you guys. So a line down, which is a wire, and then you have the big one, the medium one, and the small one going to essentially ground, like a big surface that is grounded to the circuit. So the cell and battery both supply voltage. That's why they can be used interchangeably and also drawn interchangeably. That's why it's in this theory. And supply voltage, positive and negative, you would have to beforehand you would have to say how many volts this is. So let's get on to drawing. I'm going to draw a dotted line for you guys to see where I'm getting these symbols from. So let's just do a basic circuit with a battery, a wire, a switch, and a resistor. So we're gonna let's start with the switch. So I'm gonna do that. So this circuit should be able to power on and let current through the resistor when I turn the switch on. So then I draw the battery. And as you can see, the wire, I made a bend. You can make any wire, you can make the wire do anything. So technically you can even make it a squiggle, but I'm not going to do that. I like my drawings relatively nice. So this is the battery. Now let me indicate for you guys that this is positive. So the flow is going technically from here to here. So it's like this. So now let me draw the resistor. Now all of these, I guess, intersection points are dictated with dots. As you can see, this dot right here, this dot, and this dot. So these dots mean that it intersects. Now this will be important later, for later when we're introducing motors, LEDs, and lamps and potentiometers, because there's going to be a lot of intersection points where it actually crosses through each other but doesn't connect. So as you can see, this goes this way. When you flip this switch, the resistor gets flow through it. Now I'm not going to go into like charge or energy flow or any of that. I'm just going to do basic circuits, or like basic circuit analysis essentially. So now we have motors. If we do let's make a circuit where if I flip a switch and I can choose the motor speed, this will be a DC motor. I can choose the motor speed based on the resistance of a potentiometer. So that may seem complicated, but all we're going to need is the switch, the battery, the motor, and the potentiometer, and that's it. So let me draw from the switch again. So we're going to start with this. As you can see, it looks very similar to the one we had before. And just to make it even clearer, I'm going to do that. So now we have the battery and the switch like we had before. And I'm going to do this. Now this may look complicated, but it's not going to be. Or I'm going to try not to make it complicated. So we have the looking like resistor. I'm going to, okay, well, sure, that was a little bit of a butchered potentiometer, but that's okay. So then we have this arrow. This potentiometer, anything that points to a resistor typically means that it is a potentiometer, or pot. I'm going to shorten it to pot every time I say it. Because this resistor is the brush of a potentiometer. Now, do I have a potentiometer to show you? Yes. So here we have a potentiometer. This goes to 1 mega ohm. As you can see on the top, it says B1M. The B doesn't really matter. It's the 1M afterward. So it could say 10K, which would be 10 kilo ohm, between these 2 points, and you can brush through them with this one. So if you read the resistance between here and here, it'll be the same as a typical resistor from here to here. So it's not going to change. If you rotate this dial any distance or any degrees or however you want to say it, these 2 points will not change. The only thing that will change is this, the arrow, which is the middle point. So it is I guess, A to B plus B to C is equal to A to C. That's what I am trying to say. So this is what I mean. So we have A, B, and C. These 2 values are always going to be the same. Then we have A, B, and C, and B can change. So it's like pulling on a rubber band, pulling on the middle of 2 rubber bands. And if you pull it this way, the A to B will be smaller, but B to C will be larger. So you're just changing this value in the middle. You're not changing the overall resistance. Hopefully that clears it up a little bit. Now, let's move on to the motor. The way I said we're going to be, I forgot what I said exactly, but we're going to be changing the speed of the motor to the switch and potentiometer. So the way we're going to do this is by, let's first draw the motor. So we have the motor here. Now, the positive goes from here, follow the flow. It's going to go from here, down here, and then stop. Not really. This is not a very good example, but it's going to go here, down, and then into this leg, as you can see, from here to here. So it doesn't just pass through and this does nothing. It goes into B. So it actually flows out here, and then if we attach the motor, this will be positive because positive, and then we just bring this and connect it. So there we go. Now if we adjust this to go down, it'll be the full resistance of this potentiometer, which will slow down the motor. And if we bring this up, let's say to the wire, it'll be zero resistance, or the wire's resistance. And then it'll go as fast as the battery will let it go. Hopefully that makes a little bit of sense, or hopefully I made it clear what a potentiometer does and can do. Hey guys, Editor Me here. I had to cut down about 30 minutes worth of footage because I went into explaining Ohm's law and then like all of the resistance values and voltage values and how to get current from voltage and resistance and wattage from the sample circuits that I did. So, and I also cut down a sample circuit because it was a little too complicated. It was resistors in parallel, which is the inverse relation of an inverse of two, of like one or whatever. Doesn't matter. I'll get to that in a separate video. But I hope you guys enjoyed. I hope you guys followed along with what I said. I'm not a very great teacher, so leave your ideas, comments, or suggestions in the comments down below. Like, subscribe if you want to see more, or if you just want to see some projects that I make or post along the way. So yeah, hope you guys enjoyed. Peace.